Hi everyone, in this video we are going to talk about the implementation of MLP for a non-linearly separable data. MLP is a multi-layer perceptron, which is a type of artificial neural network categorized by having multiple layers of neurons, including an input layer, one or more hidden layers, and an output layer. Each neuron in an MLP is connected to every neuron in the adjacent layers, and each connection has an associative weight. MLP is capable of learning complex patterns and relationships in data, making them suitable for a wide range of applications, including those involving non-linearly separable data. What is a non-linearly separable data? A non-linearly separable data, which is a data that cannot be effectively separated by a linear decision boundary. In other words, there is no single straight line that can be completely separate the classes or categories in the data, such as often the data exhibit complex patterns and relationships that cannot be captured by linear models. In detail, multilayer perceptron handles nonlinear separable data by introducing nonlinear activation functions such as the sigmoid and the tan h, which is also called hyperbolic, or ReLU functions between the layers. These activation functions enable the model to learn and represent complex relationships in the data, essentially for tackling datasets where classes cannot be effectively separated by a straight line or hyperplane. MLPs consist of one or more hidden layers between the input and output layers, each learning to extract increasingly abstract and complex features from the input data. These hidden layers serve as feature representation layers, allowing the model to capture intricate patterns and relationships that may not be apparent in raw input. We are going to see the implementation of MLP in using Python. Importing the necessary files. NumPy for numerical operations, pandas for data manipulation, IO, matplotlib for plotting the graphs. X is the input variable which stores the array of 2 into 4 matrix, and Y is the targeted output variable which stores the array of 1 into 4 matrix. Nx is the number of input neurons, Ny is the number of output neurons, and Nh is the number of neurons in the hidden layer. M shows the number of training samples. Lr is the learning rate. np.rand.seed of 2 with setting a random seed for reproducibility. Initializing weight by randomly. Losses is a we are setting the losses as a empty list. Activation. We are creating an activation function by the name of sigmoid. This function computes the sigmoid activation function for the given input set. Forward propagation. We are creating a function for forward propagation by it calculates the activation of A1, A2 of the hidden and output layers respectively by the given input X, respectively to the W1 and W2, followed by backward propagation. This function calculates the gradients of the weights dw1 and dw2 with respect to the loss function. We are taking 10,000 as an iteration in this for loop. in this for loop. Forward propagation, computation, propagation, and weight updates are performed iteratively. The loss values are stored in the losses list for visualization later. We are plotting losses and X label as a epochs and Y label as loss value. Creating a function to predict an input. Okay, predicting an output. This function uses forward propagation. We are just giving random inputs to predict the output of the function.